This is Nina, Nick, Davey, and George's great group project, Finding Real Response Bias Through Some Sexy Statistics, by Davey Burkhart, Nina Lynn, Nick Shankar, and George Taylor. What are we asking? That's what you're probably wondering to yourself. So, we are curious to see if some people would respond differently if they were being asked by a white person versus being asked by a black person. So we wanted to ask a question that would elicit some response bias. So we thought in our group for a while, and we wanted something that would be relevant in our community. So after a while, we came up with the question, in your opinion, is the Chicago Police Department doing a good job performing their duties? This is a question that we asked all 78 people that we interviewed. Our proportions and hypotheses. So our proportions. P1 was a true proportion of people who say yes to our question when asked by a white person. And as a reminder, our question was, in your opinion, is the Chicago Police Department doing a good job performing their duties? And P2 is the true proportion of people who say yes to our question when asked by a black person. Our null hypothesis. There is no difference in the true proportion of people who say yes to our question when questioned by a white person and black person. In other words, in mathematical terms, P1 equals P2 or P1 minus P2 equals 0. And our alternate hypothesis, which is what we test for, is that people asked by a white person will say yes more frequently than when asked by a black person. In other words, P1 is greater than P2 or P1 minus P2 is greater than 0. So how do we collect our data? We collected our data in AM support. We went through the hallways of ETHS, asking random students in the hallways, cuts, and corridors of the school our question. We had George, a black male, ask some students, and had Davey, a white male, ask other students to determine if there was response bias based on the race of the questioner. To record the data, we had Nick follow George around and Nina follow Davey around. Neither are black or white. They noted the sex, grade, race, and the response to our question, yes or no. Let's talk about the assumptions of our statistical test. So, we need random and independent samples. The samples weren't so much random as they were convenient, as we asked random people who were walking the hallways closest to us. But the samples were independent as there are no repeats, and the samples did not influence each other whatsoever. The large population argument was met. We needed to assume there was more than 10 times n being the sample size, in other words 780 students, that go to ETHS, which is true. Our third one is we need a normal sampling distribution. So normally in class we say that NP has to be greater than 10. So unfortunately we did not get that. We only got that they're greater than 5. So as a result we need to proceed with caution. So let's go deeper into these calculations. Instead of using P1, so like the proportion that Davey got when he answered his questions matched with his N, we need to pool P. That means that we need to add the proportions of George's results and my results because we're assuming that there's no difference between the two. So to calculate P pooled, we need to add 8 plus 5, which were the total amount of yeses, over 40 plus 38, which was the sample size, which gets us a P pooled of 13 out of 78, which you can see in each question. P pooled is PC, to clarify. N1 is the sample size when Davey asked the question, N2 is the sample size when George asked the question. N1 is 40, N2 is 38. So all of these numbers need to be greater than or equal to 10. We got the numbers 6.67, 33.33, 6.33, and 31.67. They are not all greater than 10, but they're all greater than 5, so it's not absolutely unreasonable to assume a normal approximation is appropriate. However, once again, we do need to proceed with caution. Remember, I cannot stress this enough, we need to proceed with caution. I think the computer's trying to tell us that we need to proceed with caution. Okay, well, that's clear enough, I guess. So here's a video of us collecting data.
In your opinion, is Chicago Police Department doing a good job performing their duties? No.
That was Davey asking the question, and here's George.
In your opinion, do you think Chicago police are doing a good job in their duties? I mean, in my opinion, I don't really see an issue in my neighborhood where I stay. So I think they're doing a good job.
Okay. So let's run the significance test. We enlisted Harvard professor Dr. Not Burkhardt to help us carry out the statistical test. Here is out-of-context findings when he plugged in the data that we gave him.
Hello, I'm Professor Not Burkhardt from Harvard University. So you need help with significance test, do you? Do you have any data? Ah, I see. Thank you. Do you have a notebook, pen, and calculator I can borrow? Okay, great. So, let's get to it. So we have our P1 and our P2. And our null hypothesis is that P1 equals P2. And our alternate hypothesis is that P1 is greater than P2. And we're going to test out a significance level of 0.1. All the assumptions are met. Okay, great. So let's get right into the test. We're going to use a two-sample z-test for proportions. So we need our z-statistic. In order to find that out, we need to calculate the two different proportions. Let's see. For this one, it is 8 out of 40. And P2 is 5 out of 38. Great. So now, if we plug these numbers into our calculator, which does the test for us, that is 8, right? Okay. Then we get a z-statistic of 0.810, and our p-value is 0.209. I'll leave you to state that in context. Pleasure working with you. Mom, did you get that?
Thank you, Dr. Not Burkhardt, for that great review of our problem, I guess. I should clarify that P1 hat is equal to 8 out of 40, and P2 hat is equal to 5 out of 38. Not P1 and P2. P1 hat and P2 hat. We paid him way too much. Anyway, so here's the data that we collected. Bask in the glory of our data. Pause the video if you need to. So there's a lot of data right here. It's very, very juicy data. Proud of it. Look at all that. Anyway, proceed now. So here's what we found from our data. Before we get into these words, let's analyze the graph that we see in the right of the screen. This is a graph of the normal spread of the null hypothesis. We got a z-statistic of 0.8105, which rendered a p-value of 0.2088. The p-value in context means that there is a 20% chance to get that the proportion of people who say yes to our question when asked by a white person is 8 out of 40, and the proportion of people who say yes to our question when asked by a black person is 5 out of 38, if we assume there is no difference in the true proportions. In other words, this is a normal spread of the null hypothesis, and 0.2088 is the number that we get from our data, assuming the null hypothesis is true. 0.2088 is quite a large p-value. That's 1 in every 5. That is not very likely. So back to our findings. As you can see from our graph, our z statistic is 0.8105, which renders a p-value 0.2088. We ran our test at an alpha of 0.1 significance level, so we're going to fail reject our null hypothesis because our p-value is greater than alpha. 0.2088 is greater than 0.1. In conclusion, we do not have statistically significant evidence to say that there is any response bias due to the race of the questioner when asking the question, in your opinion, is the Chicago Police Department doing a good job performing their duties? So what are some things that we could have done differently to get a better response? In other words, what could we have done differently in order to reject the null hypothesis? We need to ask more people. Assuming our p-pooled value stayed the same, we just needed to ask more people. Our NPC and N1 minus PC values, which determine if a normal approximation is appropriate, were all greater than 5, but not all greater than 10, which is the true number that we need to meet in order to assume that a normal approximation is appropriate. We also need to ensure that our sample is more random. We went around asking students in the hallways, which is a convenient sample really, not a random sample. If we want to randomize perfectly, we would use a random number generator after blocking by race, and ask students whose numbers were selected. We needed to make sure our data collectors were the same race as the question askers. So we needed 2 white people and 2 black people. Also, gender could have influenced the response. So, that is our presentation. Specifically, Nina, Nick, Davey, and George's great group project finding real response bias through some sexy statistics. Thank you for watching.